so let's talk about Charles Darwin, because Darwin is famous for his work. He was a naturalist, and he went on this voyage on the HMS Beagle. So he basically sailed around the world so that he could look at different animals in different places, and he started to notice a lot of similarities. He was sailing around South America, and he was on the mainland for quite a bit of time, and he was looking at different species and drawing them and finding samples. He would actually catch birds and keep them and then compare them to birds in other locations. And then he went to the Galapagos Islands, which are off of South America, and he noticed that although the animals were different, there were also a lot of similarities with animals on the mainland. So Charles Darwin came up with his theory of natural selection, and this was a mechanism for evolution, because a lot of naturalists had looked at the fossil record, and they had looked at different animal species, and they had thought about the differences and why there were differences. But Charles Darwin, he actually came up with a mechanism for how this would work, how these animals would change over time. And natural selection is what he came up with. So this is also called survival of the fittest, but that can be a little misleading. So it's not really always biggest, strongest survives, but the bird example is really good. So let's look at this. All right, so there are green bugs and there are brown bugs, and these bugs live on the bark of a tree. And so the green bugs, they show up pretty well, and the brown bugs are basically camouflaged. They're hidden by the tree. So the birds, they come along and they eat the green bugs, and they're very happy to do that because they can find them, they can see them easily, and they can pick them off rather well. Well, what would you expect would happen if the birds are eating all the green bugs? Then the brown bugs are going to be more plentiful. So these brown bugs are going to survive, and they're going to reproduce more than what the green bugs would do, because the green bugs are getting eaten, so they're not going to reproduce. They're dead. So these brown bugs will survive and reproduce, and that's basically the idea of fitness, is the ability to survive and reproduce. So when we talk about how fit an animal is, that's not necessarily how strong or how fast they are, unless that really does help them survive and reproduce. So Darwin's theory was based on several steps. The first thing was overproduction. So Darwin said, there are a lot of that species, okay? So they overproduce. And they have variation. So within that species, there are small variations that occur that make them different from each other. Okay, so this shows some variation in birds. And selection acts on that variation. Okay, so there's always a selective pressure, and it could be a predator, it could be something in the natural environment, it could be how much food is available, it could be an environmental force like the cold or the climate. And because of these things, adaptation will occur. So adaptation would be basically how well that particular species survives in that environment due to its traits. And so you'll see in this picture that this bird right here is a little bit camouflaged, so maybe that eagle wouldn't see it. Maybe it's not going to get eaten. So let's talk about adaptation and how it occurs, because there can be a little bit of confusion about this. There was a scientist named Lamarck who thought that if an animal used a certain trait more and more and more, then it would develop an adaptation. So the giraffe is kind of a famous example of this, because So here, this giraffe wants to reach these tall leaves. He has a short neck, but he's reaching and reaching and reaching for those leaves. And so over time, what Lamarck thought was that neck would lengthen and it would eat the leaves. This one over here that's eating the short shrubs, its neck would not get longer. And so you would end up with two different kinds of species. You would end up with one with a short neck, one with a long neck. Well, that's not really how it works out, because this would be like saying that, okay, this one developed a long neck because he needed it, and then he would pass that on to his offspring. And we know that doesn't work. So think of a bodybuilder. A bodybuilder builds up really good muscle tone, really great big muscles. Do they pass that on to their offspring and their genetics? No. Now, maybe they work with their kids and they help them to be fit, but that's not adaptation per se. Adaptation is genetically based, okay? So it's really important to know the difference. This little guy, he might be stretching to reach those leaves, and maybe he is lucky that his genetics gave him a longer neck. So it's the genetics that give the favorable trait, okay? So he's lucky, he has a little bit longer of a neck, and so he gets to eat more, and he gets to reproduce, and he has more offspring, and that is what allows him to adapt. And so we see that change in the species, not because he used his neck to stretch, but because he was favored with this genetic adaptation. And so he was able to pass that along to his offspring. So an adaptation is any trait that gives the organism a fitness advantage. So he's born with a longer neck. That's in his genes, and that gives him the advantage of being able to reach those leaves on the tree. And so he's able to pass that along to his offspring. All right, so we have some patterns of evolution that we're going to talk about. The first one is convergent evolution. So in this case, we have two species that are living in the same area, and so maybe they're eating the same type of berries. And so if you look at these beaks, they are very similar. And so that's convergent evolution. They're in the same area, they're sharing the same resources, and so their traits will develop in very similar manner. The next one is coevolution. And in this one, the animals are living in the same environment. And so think about this lion here. This lion is very fast. And that serves her well because she's going to chase down the zebra and she's going to eat the zebra, okay? And so if this zebra is slow, it's going to get eaten, okay? That's just kind of the way it works. It gets eaten. But let's say this zebra was born with a trait that made it fast, and it outruns the lion. And so this zebra survives and reproduces and passes on that fast trait to its offspring. Well, these guys co-evolved. So the lion has to be really fast to catch the zebra, and so it passes that trait on fast. And the zebra has to be fast to outrun the lion, and so it passes that trait on. So they have co-evolved together. The faster lions reproduce more, the faster zebras reproduce more. The next one is adaptive radiation, and this is really what Darwin saw on the Galapagos Islands. So let's say you have a bird that is on the mainland, it's on a continent, and it's flying around, and it flies out over the water somewhat, and a storm blows it to an island where there are no other birds, okay? So I should say this group of birds got blown to an island because one individual is not going to reproduce on its own, but this group of birds is blown off course. It's on this island now, And there's a lot of food sources because there weren't birds there before. So there's lots of berries, there's lots of bugs, there's lots of nuts. And so as this bird species survives and reproduces on this island, it's going to fill in these niches, these ecological areas where it can feed. So, these birds are living on this island, they're reproducing. Some of them are mainly eating the berries, but other ones are mainly eating the nuts, and other ones, maybe they're predators and they're eating the bugs. And so they call this a radiation because as these guys fill in these niches, they're going to be changing. Their traits are going to be adapting, which means that, say, there's like the birds that are eating the berries, maybe a mutation makes their beaks better designed for that. And so that's the trait that would get passed along within that set of birds. Over with the birds that are eating the nuts, maybe their beaks, maybe there's a mutation in the population that makes the beaks stronger. And so that mutation would actually get passed along and would help those birds. And so we see these changes, and they're kind of based on what the birds are eating in that particular area. Now, it's important to remember that the birds are not thinking, oh, I need to adapt, I need to change my beak to make it better to eat berries. It's really based on chance. If there's a mutation that occurs that is helpful, then that mutation will get passed along. Now, mutations can also be harmful. So if there's a mutation that occurs that is not helpful, well, that particular species, that particular bird is probably going to die out. It didn't help it, it doesn't get passed along, and so we don't really see those genetic traits that are not helpful in the environment because they kind of get weeded out. They're not helpful, they don't help the animal survive and reproduce, and so they're not going to show up as often. The next one is extinction. This is actually a pattern of evolution. So extinction events can occur. Large extinction events, we see that there's a lot of adaptive radiation after that. So, for example, when the dinosaurs went extinct because of whatever extinction event occurred, a lot of people think it's the meteor that hit, but very small mammals were able to adapt because mammals at that time, they were very small and they really were hidden, okay? So they lived in burrows and they lived in caves, and so they weren't really running around under the dinosaurs' feet because then they would have gotten eaten. But because they lived in burrows and they lived in caves, a lot of the damage from the extinction event and the cold and things like that didn't affect them as badly, and so they were able to survive. And then they kind of radiated out from there, and we saw this large increase in mammals after the dinosaurs went extinct, probably because they weren't getting eaten as much. Kind of makes sense, right? All right, some other patterns of evolution. We have gradualism. So this is a model where species will change over really long periods of time, and this would be due to, genetic changes that occur one after another, but it's slow and it changes over a long period of time. Whereas the punctuated equilibrium would be something like after an extinction event where they're filling in a new area, and so there might be this rather sharp change. And so you would maybe see that particular genetic trait was very helpful and other traits were not very helpful. And so you see this immediate change rather than a gradual change over time.